Circles number 3. I can find the lengths of chords, secants, and tangents. So just a quick reminder here, if you don't remember what a chord is, if here's my circle, a chord is a segment that has two endpoints on the circle, okay? So that would be a chord. A secant is a line, a line or array, I guess, that goes through the circle. So it could be a ray technically, or a line if you wanted to put an endpoint on, or an arrow on here instead of the endpoint. All right, a line or a ray that goes through the circle intersects it twice. Okay, I got two intersection points. That's my secant. My chord is a segment, and a tangent is a line or a ray that intersects the graph at one point. Okay, it just touches it right there at one point. Okay, so tangent, secant, chord. All right, so if first part we're going to do is intersection of two chords. If two chords intersect in a circle, then the products of the measures of the segments of the chords are equal. So in the circle, the two chords A, C, and B, D intersect at point E. So AE times EC is going to equal DE times BE, okay? So if you think of it, if I use some colors here, AE times EC is going to equal DE times EB, or in other words, part times part equals part times part. So you just multiply the two pieces that they're divided into times each other. Okay, so if we go here, I gave it to you nice and color coded here. So it's going to be 40 times X equals 25 times 38. So this will give me 950 divided by 40 gives me 23.75. Since that's an exact decimal, I will leave it. Okay, I come over here. X times 21 equals 14 times 34. So I'm going to make that 21x instead of x times 21 equals 476. And I get a repeating decimal. So I'm not going to round it. I'm going to, unless it says specifically in the problem to round, I'm going to convert it to a fraction. So I'm going to hit the decimal to fraction button on my calculator and then convert it to an improper because I like impropers better than mixed numbers. And that's what we get. All right. Pretty easy when you have two chords intersecting. Part times part equals part times part. All right, so two secants now, okay? So basically it's going to be outer segment times the whole segment equals outer segment times the whole segment, okay? So in terms of this picture, MN times MN plus NO equals MP times MP plus PQ, okay? All right, so outer times whole. So if I look at the blue here, it's 4 times, add those up, that'd be 14 equals outer times whole. I have to add those up. It's 5 plus x. Okay, got to do a little bit of algebra here. Okay, so this will be 56 equals 25 plus 5x when I distribute. I get 31 equals 5x. Divide by 5. And I'll tell you what, I'll just leave it like that. 31 over 5 equals x. Okay. Same idea here. Outside times whole. 36 times x plus 36 equals outside times whole. So it'll be 37 times 52 when I add the 15 and the 37. All right, a little bit of algebra here. 37 times 52 is 1924. Distribute the 36. All right, let's get the x by itself. So again, I get a repeating decimal. It's 19.4 or 17.4 repeating. I'm going to convert that to a fraction. So that ends up being 157 over 9. Okay. All right. The third thing that you could have is secant right here times tangent. Okay. So for the secant, it's outer segment times whole, just like we did. And then it equals outer segment squared. Okay. So if you look here, uv squared is my tangent. And then this is my secant. So it's outside times the whole thing. Okay. So when I come over here, it's going to be 18 times 18 plus x equals 27 squared. And let's see here. Let's do a little bit of math here. 18, distribute that. You get 324 plus 18x equals 729. So I get 18x equals 405. And this is an exact decimal, so I'll just leave it. So it doesn't say in the problem how to write it. So anytime they don't say how to round or how to write your answer, I would only write exact answers. So since this decimal terminates, it's fine. Over here, it's going to be outside. Let me use the same colors. It's going to be outside times whole equals outside squared. So this is a little harder because now we have an x squared, but we should be good with that. We've done it plenty of times with the Pythagorean theorem. So this ends up being 1457. And I square root both sides, and I get, I don't know if that's a perfect square. Square root of 1457. It is not a perfect square. So, as a decimal, if it's said to round, you'd put it as 38 point, I don't know, maybe round to the 100, 38.18. If you did not, if you wanted it as an exact answer, we'd have to see if any perfect squares go into 1457. So you're going to start dividing it by all your perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, 64, 81, 100, 121. Just start dividing it, see if any of these numbers go into there, and if it does, then you can pull those out. So I'm going to start dividing it here. All right, 169 doesn't go in, 144 doesn't, 121 doesn't, 100 doesn't, 81 doesn't, 64 does not, 49 doesn't, 36 doesn't. I don't think any of these are going to go in evenly. So if you wanted to leave it as an exact answer, you could leave it as the square root of 1457 because it doesn't simplify. So either one, depending on what the direction said. If it said to round appropriately. If it said leave it as an exact radical, you could leave it like that. Try to pull perfect squares out. Like, so, for instance, if just to make sure we understand what I mean when I say that, if I had the square root of 300, okay, well, 100 goes into 300, so that would be 3 times 100. And then when you take the square root of the 100, that's 10. So that would become 10 radical 3. Okay, so just make sure you understand how to simplify a radical in case that's how the answer is supposed to be written. All right, that's it for this lesson.